Hello, and warmest of Septandy greetings to you and yours. As you may be aware, I just wrapped up my series on exploring some old code I wrote in high school for an assembly language Moon Patrol game clone that I never finished. Today, what I'm going to do is have present-day me make the first change to that old code base written by past me. And I'm going to do something a little different. I'm going to make some changes and not run them until you see me run them for the very first time, which means they will probably have bugs, and then I will show you me trying to debug those bugs. I'm hoping this doesn't get too boring. Could go either way. I don't know. Let's find out. So the first thing I'd like to do is eliminate the need to load the sprite separately from a basic driver file. So since I'm using lwasm, I can do this INCLUDEBIN sudo opcode and then just include them this way. But you gotta be careful. So as you may recall, the very beginning, this is what I used to call data.bin. You've got your preamble up here and your postamble here because I was creating this from a basic program. I would draw the pictures and then poke the bytes from the screen buffer into a range of memory starting at hex 6000. And then I would save m it. And since I would save m inc it, this basic would add the preamble and the postamble. So what is lwasm going to do? Well, if we look at the listing file it generated, here's the INCLUDEBIN sprites. Sure enough, we got the 00, 01, A9, 60, 00, 01, A9, 60. So it's including that. So what I'm going to need to do is just modify this to get rid of those bytes. So I just discovered that the hex editor plugin for the VS Code tool does not let you delete bytes from a binary file. Right before your very eyes, I discovered that. So now I'm using this Windows tool, Microsoft Store tool, hexed.it. It seems to do the trick. Let's verify that. We're opening up sprites.bin. Here's my 1, 2, 3, 4, 5 byte preamble. Let's see if we can delete those all at once. Oh, nice. Okay, and my 1, 2, 3, 4, 5 byte postamble. Okay, and we save. And loading that back into the VS Code hex editor plugin, this looks about right to me. So now I just include that binary file here, and then I can use this label to refer not to a hard-coded 6000, but to wherever this starts. And then these, which were based off of this, I just moved down here. And I'm going to do the same thing. We had two backdrops, Moonpick 1 and Moonpick 2. I don't think I've even been demoing Moonpick 2 with the scrolling and with the moving code, but now I can include both of these in here and then add code to copy those bytes to the screen depending on which backdrop we're supposed to be using. So I will just edit the preamble and postamble of each of these in the same way, and then I should be able to include these files. So this means I already have this incorporated into the assembly code, and I've just done the two moon pictures. This is the assembly code, and I just added code to set the display mode, which means I should be done with my basic driver file. So at the top of the main loop, I'm now calling this set display mode. It sets the screen buffer to start at E100. It sets the SAM control bits so that the buffer size is hex 1800, And it sets the operating mode, so this would be the equivalent of 3,1. If you're curious how I knew to do this, I have several videos about controlling the VDG and the display modes. So I'll leave links to that in the description, and feel free to take a look at those whenever you're curious. And at the bottom of the main loop, I added this. So it will now be looking for keystrokes to make changes. So exec keyboard commands looks for either a 1 or a 2. And if it sees a 1, it will copy the moon picture 1 into the screen buffer, and if it sees a 2, it'll copy the moon picture 2 into the screen buffer. So it should be able to see both screens at will and flip back and forth between them. And these are fairly simple. Copy moon pic 1, sets the U register to point to where moon pic 1 got loaded, and just as a refresher, that's right here. So we have that labeled just before the include bin. And moonpic 2 instead loads U with moonpic 2, and then they both fall into here, which loads X as the destination of the copy. So we're going to be copying from the moonpic 1 or 2 into the graphics. This tells us how many bytes, and then copy byte is the subroutine to do the copy. And copy bytes is, as you would expect, we just basically have a while loop, and as long as our counter is non-zero, we will load our bytes from U, store them into D, and then we decrease our counter by 2. I have not run or tested any of this. I do not know if it works, but if I had to take a guess, there's no way it works, because, like I said, I haven't run or tested it. I'll put you into high-speed mode just for the loading, because there's a lot to load. That was very fast. All right, let's see. Yeah, that's how it always goes. Goodness knows. All right, actually, maybe that's normal. I haven't hit 1 or 2 yet. I'll hit 1. No, yeah. 1, 2, 1, 2, 2, 2, 1, 1. All right, got a debug. Oh, this could be my problem right here. I'm loading the stack. This is the very first line of code. My stack register is starting at 5500. And my code goes down to that would be handy if I add a little label to tell me, but it's basically going down to well beyond that. Boy, this is a lot of code, huh? Jeez Louise. Starting here and it's going down another 1800. This is, holy cow, how is my code that's barely doing anything taking up all this room? Oh my gosh. I got no room for the stack or anything. Well, one thing I could do is start my code much earlier. So the only screen memory I need starts at E100 and goes up by 1800. So in theory, I could actually start at 2600 and not all the way at 3F100. Let's try that. 2600 and my exec address 2600. And as for my stack, I'm going to leave that alone. I think the default is going to set that to be pretty high anyway. Alright, so if and you know what else? I'm also going to add another label to help me out here. End data. So now, end data is at 601F. Okay, that's more manageable. I'm going to try this in the debugger initially. That way I can see what my default stack address is going to be. 2600. Alright, so my stack starts at 7F33. That should be plenty of room. Okay, let's run it. Let's see what happens. Okay. Can I hit 1 or 2? Rats. Oh goodness. Somehow I ended up at 4, 5, 7, 8. Yeah, somehow I'm executing code right in the middle of my pictures. Why am I doing that? How did I end up executing code in the middle of these pictures? Let's just use the debugger. Alright, so first we set the display mode. That's what happened there. Oh, and then like... Don't tell me I forgot an RTS. We're already in Never Never Land. Oh my gosh. How come none of you told me about this? Crying out loud. Am I feeling lucky enough to just try it? Yes. Unjustified feeling of luckiness. Oh, look at this. Something is happening. You can see the reflector effect and everything, so I'm going to try to bring in... nope. I'm hitting like 1 and 2 to try and bring in the moon pictures, but that doesn't seem to be doing anything. Alright, exec keyboard command is 2E12. Very good. So what does it do? Calls polecat. Polecat didn't return anything, but I'm going to set a breakpoint here for when it does. Get rid of that one. Continue. Hit the number 1. And so A is 31, and that is number 1. That makes sense. And so we're going to load U at the beginning of moonpic, so use a 3020. Then we copy it, the graphics is E100. And then we go to copy those bytes. So we're going from 3020 to E100, and this is D. We lower Y by 2, and then we, oh my god, I forgot to branch up. Are you freaking kidding me? Come on, man. Did you all see this and no one said anything? Crying out loud. Alright, I'm sure it's going to work now. Okay. Let's hit the number 1. Yeah! Yeah! Let's hit the number 2. Yeah! Check it out! I don't know what this little yellow dot is though. That doesn't look right. Number 1. Number 2. Is that yellow dot always there? What the heck is going on with that yellow dot? 2. Oh, each time I hit 2 it like restarts it. 2, 2, 2, 2, 2, 2. 1, 2. Haha. Yeah. That's what I call kinda working.